So if in this case, I decide to take next move, how many moves are there? I can move this 7-way, move this 7-way, move this 7-way. So 7 into 1, 2, 3, 4, 5, 6, 7, 8. 56 child nodes are there, and for every of those 56 child nodes I will have certain heuristic function value, and that heuristic function value will tell me which is the better option to choose from amongst the options that I have. So what is the current value of my heuristic function given this scenario? I need to just count how many queens are attacking each other. So what is the attacking queen? Attacking queen is a queen pair is like this. So these two are attacking each other. These two are attacking each other. This and this is attacking each other because they are in the straight line of sight of each other. Okay. Similarly, these two queens are attacking each other. So I just want to count the number of pairs of queens that attack each other, and that count for this configuration, they have already done it for us. We won't waste our time in doing it. 17. So what will be my goal for an 8 queen problem? I want to adjust all the 8 queens on the board without no 2 queens attacking each other. So I want a placement of 8 queens such that the number of pairs attacking each other is 0. So my H desirable is 0. And worst case H is some higher positive number. So I need to take this number down to 0. That is how I will be adjusting my hill climbing algorithm. Actually, this is now a going downhill algorithm where the H value I'm trying to reduce. Okay, we are not going to solve this problem, but if I want to apply hill climbing algorithm to 8 queens problem, this is how I would have to define the problem. I would have a full configuration or full representation on the board. I will place all the 8 queens in 8 different columns, and then my algorithm would start counting what is the H value. And then the algorithmic step will try to only replace current node with the next node if my H value is getting reduced. So in this case, 17 is the H value. So if you see, there are many nodes, and there are many nodes with value 12. So these are the nodes which are the candidate nodes to choose from for being the neighbor of my current node. Current state का neighbor होने के लिए ये candidate nodes है जिनका value 12 है, because 12 is the least value of the H function, which can be used as one of the objective functions. So hill climbing can also incorporate domain information like inform search algorithm used for defining the objective function. Here the objective function is defined as I want to have H to be 0. That's my goal node's objective function value. And for my initial state, one initial placement, maybe this initial placement, H value is 17. So I don't want to go from H value 17 to any other H value, that is H value 18, H value 19, the higher H value. I want to go down from here and reach H0. And many of people have tried this out. Now this is same problem. After certain iterations of hill climbing algorithm, the algorithm would halt, and it will halt because in this is a local maxima where अगर आप देखोगे तो यहाँ पे सिर्फ एक पैर अटैक करता है एक दूसरे को. कौन सा पैर वो मुझे दिख नहीं रहा, but you may actually find it earlier than me. There's only one pair of queens which are attacking each other. No other queens are attacking. So this queen does not attack any other queen. This queen does not attack any other queen. This queen I can visually check, right? Visually कि chess आपको पता है queen horizontally, vertically और diagonally attack कर सकता है. Similarly, I don't find any queen attacking each other. Why so? Can you find any pair and tell me if I number the cells from 1 to 8 and 1 to 8 like this? Can anybody tell me which pair is attacking each other? Tell me the queen pairs that are attacking each other. They say there is only one pair, and I'm not able to find it out. Somebody who is good at chess.
4 or 4.
Yeah, this and this. Yes, 4 and 4 and 1 and 7, right? So these two queens are attacking each other. Diagonal attack is there. So this is the only pair which is attacking each other. Now if you check any movement, so ये आपको ये जो अटैक है वो अवॉइड करना है, तो ये दोनों में से एक क्वीन को हटाना होगा. बाकी के क्वीन का प्लेसमेंट तो लगभग ठीक है, ऐसा कंसिडर करेंगे. तो इफ आई एक्चुअली मूव दिस क्वीन ओवर हियर, आई विल हैव इट अटैकिंग दिस अदर क्वीन and this other queen. So now there will be, if I move this queen, or if I decide to move this queen over here, okay, what will happen is my h is now 2 at least. इससे ज्यादा बढ़ेगा नहीं बढ़ेगा मैं एनालिसिस नहीं कर रहा हूं, लेकिन h का वैल्यू 2 तो हो गया. I have found 2 pairs of queens which are attacking each other. Even if I make this queen come here, then also it is at least 1 and 2, right? Similarly, you can check with all the other options. 56 options are there. You see how much breadth of the tree it is having. 56 moves are possible from here as well. So every step I can do any 56 of the moves. Okay, more than 56 actually, I should say. But there are a lot of moves. That is what I mean by saying 56 moves are allowed. तो ये पर्टिकुलर जो स्टेट है, इस स्टेट से आप कोई भी मूव करोगे आउट ऑफ दोस 56, ऑल द नेबरिंग नोड्स विल हैव h value greater than or equal to 1, and that means this is the local minimum. And this is how you can realize what is local minimum by in a problem setting. In a problem setting, this is how a local minimum is reached out. And now this particular is a variant of hill climbing algorithm called as simulated annealing. Now what is annealing? So in metallurgy, whenever I want to shape a metal, or whenever I want to change the properties of metal and give it a particular kind of tensility and strength, what I do generally is I heat up that metal to a very high temperature, and I try to get the temperature down suddenly by cooling it down randomly. And again I keep on heating it and cooling it down, heating it, cooling it down. So first time when I start the process, I heat it up very much and I cool it down with certain, after certain time I provide it the heat. ओके तो ये जो कंटिन्यूअस प्रोसेस है, शुरू में बहुत ज्यादा गर्म करना पड़ता है, फिर आप उसको थोड़ा कूल करोगे, फिर थोड़ा गर्म करोगे, बिकॉज वंस आई टेक अ टेम्परेचर हाई इनफ, the cooling effect will not bring it completely down. So again I'll heat it up, again it will be brought down, again I'll heat it up, again I'll brought it down. Every time at a different level the heat would recede. लेकिन ये जो प्रक्रिया होती है, ये जो प्रोसेस होती है, that process is called as annealing of metals. And annealing of metals does what? It gives the enough hardening or enough shine or enough certain physical qualities to the metal. ओके ये जो अनीलिंग का प्रोसेस होता है वो किस लिए किया जाता है? मेटल में कुछ प्रॉपर्टीज जो है वो होते नहीं, उनको लाने के लिए किया जाता है. So we want to add certain different properties to the metal. This is what is the process of annealing. And we try to actually use this process for solving the problems of not getting to the goal node that we have in the goal node means the optimal solution, that is लोकल मैक्सिमा को रुक जाता है मेरा एल्गोरिथम, जिसको कहते हैं हिल क्लाइंबिंग एल्गोरिथम, उसको ग्लोबल मैक्सिमा तक लेके जाने के लिए वी ट्राई टू यूज दिस similar kind of algorithm. So this algorithm that you are looking at is a variant of this physical process called as annealing process. So we actually use a simulated variant of the physical annealing process. That's why the name simulated annealing process. Okay, annealing का annealing नहीं करूंगा और सिर्फ मैं एक मेटल को पूरा गर्म करने के बाद कूल डाउन करूंगा तो मेटल के प्रॉपर्टीज, फिजिकल प्रॉपर्टीज जैसे पहले थे वैसे रिस्टोर होते जाएंगे. अगर मैं अनीलिंग करता हूं तो उसमें प्रॉपर्टीज जो है टेंसिलिटी, हार्डनिंग एंड अदर थिंग्स, दे विल स्टार्ट इनकॉर्पोरेटेड, फिजिकल प्रॉपर्टीज उसके चेंज होते जाएंगे. Okay, exactly. I'm not a metallurgy engineer, so don't ask me कि सर कौन सा प्रॉपर्टी होता है, but this is what generally annealing means and why it is done. The reason behind that is, the reason is that if I only heat a particular metal and temper it later on to the room temperature back, its property won't change. But if I keep on doing this process in a scheduled manner, in a specific time schedule, if I follow, then I can actually, if I follow a certain fixed schedule, I can get that particular metal to have the desired property. That is why this name, simulated annealing. You will see a striking difference between this and the hill climbing algorithm, an added parameter, and that parameter is schedule. This is the schedule for heating up the algorithm. Now, in this case, we are not heating any metal. This schedule is telling me, giving me a random number with respect to time, where we will decide to add a random choice, a randomization choice. Okay. So what was the problem? The problem was, whenever I was leading the local minimum, I was not allowed to choose a bad choice. These were bad choices. That's why we were avoiding to choose them. But what now we are going to do is, after I reach a local maxima, or even if I do not reach a local maxima, I allowed my algorithm to take certain wrong turns, certain wrong choices. And what it will do is, it will allow me to navigate certain scenarios like this. So if I allowed myself to take a wrong turn, I may reach this part and I may able to navigate to higher peaks. This is what is allowed by this algorithm. Algorithm is not that straightforward to understand by looking at it once, लेकिन आप अगर थोड़ा ध्यान दोगे तो आपको समझ में आएगा. इनपुट्स में एक इनपुट बड़ा है जिसको शेड्यूल बोला गया है. What is that? That is a mapping from time to temperature. So this word temperature comes from the annealing process. Temperature का मतलब है, this is a constant T that will control the probability downward steps, probability of taking a downward step. Okay, so ये जो है, ये एक exponential function है, e raised to delta e divided by t. तो ये e raised to delta e divided by t change होगा जब मेरा t change होगा. Okay, and t is adjusted such that sometimes I allow myself to take downward steps, sometimes I'm prohibited from taking downward step, and this happens in a randomized manner. So this schedule T comes as a random mapping. Okay, hence we are actually trying to do what? Trying to change the nature of the algorithm, which was very smoothly traversing the state space landscape. It was just, if it were here, it was just climbing ahead, but we actually allow it to decelerate and go back sometimes, and then allow it to go ahead. Okay, it will create problem in navigating smoothly increasing slopes, because you may actually lose certain good steps because you are allowed to go downward, take the downward turns, but then it will allow you to take certain positive navigations as well. Okay, and you can reach the global maximum ultimately because you are running it in a randomized fashion. Okay, again from initial state of the problem, create a node, put it in current. यहाँ तक का algorithm ठीक है. You are repeating up to infinity and you are remembering this time. ये time क्यों use होगा? ये हमने for loop लिया है. देख क्या होगा, इससे पहले सब while loops थे. Okay, because we want to now have a schedule from which we can map a particular time to capital T value. So we are mapping, we are actually mapping the time of a particular event to a constant T, which is a function constant that computes an exponential value over here, which represents a probability choice, probabilistic choice, I should say. Okay, I get the t value. If t is 0, then return the current. So t अगर 0 आता है तो इससे आगे ये problem नहीं जाएगा. You are just given up solving the problem. If t is not 0, then you will do what? You will not now compare or do anything. You just find any random successor of the current node, put it into the variable next. Okay, वहाँ पे neighbor variable था, यहाँ पे next variable है. वेरिएबल के नाम चेंज हो गए. नाउ व्हाट आई विल डू, आई विल कंप्यूट द एरर और कंप्यूट द डिस्टेंस बिटवीन वैल्यू ऑफ ऑब्जेक्टिव फंक्शन फॉर नेक्स्ट स्टेट टू द करंट स्टेट. दैट इज माय डेल्टा ई. सो व्हाट इज द डिफरेंस बिटवीन value of the next against the current node, and then I will divide this delta E by T when I'm doing the randomized choice. So these two steps now are very important. If delta is greater than 0, इसका मतलब है ये जो नया वैल्यू है ये अच्छा है पुराने वैल्यू से, I can always update the current node with the next. So please see that we are doing a random choice between the successor nodes. पहले ऐसा नहीं था, मैक्सिमम वैल्यू सक्सेसर नोड को हम लोग नेबर में रखते थे. सो दैट्स अ वेरिएशन फ्रॉम हिल क्लाइंबिंग एल्गोरिथम. यहाँ पे एक रैंडमाइजेशन ऐड किया है. दूसरा रैंडमाइजेशन एल्स पार्ट में है. जब डेल्टा ई छोटा होता है, यानी करंट जो मैंने रैंडमली चूज किया हुआ नोड था, नेक्स्ट नोड था, वो सूटेबल नहीं है ऐसा मुझे पता चलता है टू रिप्लेस द करंट नोड. तो मैं क्या करता हूँ, फिर भी नेक्स्ट नोड से करंट नोड को रिप्लेस करता हूँ. ये कितने बार करता हूँ, ये एक प्रोबेबिलिस्टिक डिसीजन है. ई रेस टू डेल्टा ई डिवाइड बाय टी इस फंक्शन के हिसाब से मैं मेरा डिसीजन लेता हूँ. सो इट्स अ प्रोबेबिलिस्टिक चॉइस. मे बी इफ यू आर नॉट गुड एट प्रोबेबिलिटी थियरी, यू माइट नॉट अंडरस्टैंड व्हाट वी आर डूइंग. सो दिस स्टेप इज नॉट अ डेफिनेट स्टेप. ये स्टेप मैं कभी करूंगा, कभी मैं उनको स्किप करूंगा. सो आई विल बी टेकिंग अ रैंडम डिसीजन whether to do this step or not to do this step whenever delta E is negative or delta E is 0. Okay, so that is how simulated annealing works. And in practice for real world problem, people have used simulated annealing a lot for a very practical problem like VLSI layout design, airline timetable scheduling. Such problems, to do optimization, people have used simulated annealing successfully to get the optimal solution. Okay, the proof is not there in our syllabus. But we can prove that as the t decreases slowly, the simulated annealing search will find a global optimum with the probability e raised to delta E upon t approaching to v to 1. Sorry. So that is what is this particular algorithm promises. Okay, so that's about simulated annealing. There is another good solution called as beam search. So keep track of case states rather than just one. So rather than keeping track of one current node, we say that we will keep 3 current nodes at a time in our memory. Okay, so I may have a large state space, okay, huge state space like this. Okay, initially, rather than just saying that current node is the initial state, I will pick any 3 nodes in the whole state space as my initial node. Just like मुझे नहीं पता आपको पता है या नहीं, did you had last semester random forest algorithm in machine learning or in data mining? Did you had or heard of this algorithm called as random forest algorithm? Instead of